up after Thanksgiving break. Okay, so we'll start off with this Would You Rather, and we have your campus publishing the average parking fine and the median parking fine. I want you to think about this before you move on in the video. We have one student who has accumulated $900 in parking fines over a single semester. With that in mind, would you rather see the campus police post the mean fine, the average, or the median fine to know what most students typically pay in parking fines and why? So right now I want you to pause the video and reflect on your response before moving on. And we'll take a look at a set of data. So here we have a set of data, parking fines issued to students this semester, and you can see that student with the $900 bill is in there, and it looks like we have 10 students, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we say n equals 10. And we're first asked to find the mean of the data set. So we want to find the mean. That means we're going to add all the values, and divide by the total number of values. Okay, so that's the same as saying that the mean equals the sum of all the x, that's the values, over n. So if you look at my calculator on the right, I've already typed in those 10 values, and I have a sum of 1185, and there were 10 students. I'm going to divide that by 10. It's parking fine, so I'm going to write that as a dollar amount. $118.50 is our mean of the data set. Okay, now let's look at the median. For the median, that's the middle value of the data set. We need to put all of the values in order from smallest to largest. Okay, so I see 15, 20, there's two 25s, a 30, 35, 40, 45, 50, got that. Okay, I'm crossing off as I go so I don't lose anything. And then the big one, 900. Okay. The middle number, probably what a lot of you have done in the past when you've done median, is cross off each end. Please feel free to continue doing that. Since it's 10, I know that 5 values from each end splits the data set. So I see 5 and I see 5. So I know my middle value is going to be right there. That means our median is the middle of 30 and 35. So I'll need to, I know it's going to be 32.5, but just to show you in case you want to work it out like that, is taking the two middle values, 30 and 35, and finding the average of those. So 65 divided by 2 gives us $32.50 for our median. Comparing those two, $118.50 for the mean and $32.50 for the median, which one makes more sense for the college to post as the typical parking fine, and why? Well, think about that $118.50. Nobody else in the data set had a fine that was even close to that. The $900 fine is pulling the average to make it look like the average is actually higher than it really is, where the $32.50 from the median is probably a little bit more realistic. Well, it definitely is more realistic. So we'll say that the median makes more sense, for them to post as the typical parking fine. And so we'll talk about that a little bit more in just a minute, but while we have this data set here, I do also want to get us to calculate the mode and the mid-range. So your mode of the data set, I know you guys know this, is the value that most often occurs, right? And so our mode here, we had that 25 that popped up twice. So we had 2 students with $25 fines. So our mode is $25. Our mid-range, what our mid-range does is takes the average of the high and the low. So basically cuts your minimum value, your maximum value, puts them together, cuts them in half. So we take the 15 plus the 900, divides that by 2. That's the average of our largest and our smallest value. So 915 divided by 2. And we know 900 divided by 2 is 450. 15 divided by 2 is $7.50. So we got $457.50 as our mid-range. Interesting. Let's talk about some takeaways here, right? So what happened to that mean in that mid-range? That extreme outlier of $900 drastically increased that mean and mid-range. That mid-range is going to be somewhere in here, right? That $457. Here's 100 here. So the mean is going to be somewhere in here. The mean at $118.50. I know this is a little difficult to see, so I'm going to zoom in right here a little bit. The median is always going to be the middle line in your box plot. Right, so there's our median, and we got $32.50 for that one. Okay, so what I want you to see from this box plot is what that extreme outlier does to some of our calculations, some of our measures of center. It pulls that mean in that mid-range out towards the outlier and away from the rest of the data set, right? So all those other values were 50 and less down to 15. That mean makes no sense to report it as the typical value. But the median is right there in with the rest of those data points from 15 to 50. So what we say is what happens when you have an outlier present in your data set, the median is the better measure of center to report as the typical value than the mean. Otherwise, if there is not an outlier, then we would use most often we would use the mean. They should be pretty close if you have a symmetric data set. They should be very similar, the mean and the median. Actually, let's go ahead and I'm looking at my calculator over here on the right. I'm going to take out that outlier of 900 just so you can see. Without the outlier, we would have, without the outlier, we would have a sum of 285, and then we would divide that by 9 because we took the 900 out. So 285 divided by 9. We would be right there in line with the median at $31.67. So you can see again how much that outlier has affected the mean. So moving on, just looking at some of your definitions here in calculations, just as an overview. We want to think of the mean as being the fair share value. If we were to equally distribute all of the data points out, that would be the balance point, so to speak. So we take the sum of all the data and divide by the number of points in the data set. Or if you're looking at it as a formula, you'd see the sum of all the x values divided by the total sample size. Your median is that middle value in the ordered list. It is important that you have your data in order from smallest to largest for that. And then 2 things are going to happen. If you have an odd number in your data set, then it's just going to be the middle value that you come across. If there's an even number of data values in your data set, then you take that average like we did with the 30 and 35. Add the two middle and divide by 2. Your mode is the value that appears most often. One thing I wanted to highlight to you on this is there's no calculation for it. You have to be diligent in looking at your list of data to make sure you identify the value that repeats the most often. Here's something else to note as well. It is possible for a data set to have no mode. That means there's no repeating numbers. Or it is also possible for there to be multiple modes. If we had 2 students that had $50 fines instead of that $900 fine, then we would have had 2 modes for that example. Okay, your mid-range is the value exactly halfway between the smallest and largest, or your min and your max of the data set. So you take the minimum and the maximum and divide it by 2. These two also are much easier to find or calculate once you have your data ordered like you did for your median. Okay, so we'll finish off with one more example just to make sure you got it, and then we'll wrap up. So during a typical hour on campus, a sample of I was changing this, and we're going to make that 9 students. Okay, because this example makes no sense to have 90 minutes there because it's a typical hour on campus. So there's only 60 minutes in an hour. I have a sample of 9 students who were asked how many minutes they were actively on Wi-Fi. We have their responses and we're asked to find the mean, median, mode, and mid-range. Let's start with the mean. So we need to add all of our values. So our mean, we add all of our values and divide by the total number, which in this case would be 9. Go ahead and take a moment and add those numbers up. You can see I've already done that in the Desmos calculator on the right over here, and we end up with 414, and we'll divide that by 9. And we get a mean of 46. Next, for our median, we want to make sure we have our data in order. So looking for the smallest value, I see a 38, then a 39, 40, 41, 42, 40, 41, 42, 45, 52, 57, and 60. With those in order, and there's 9 of them, we can see 4 each way. Okay, and again, feel free to cross off like this as you go. That leaves our median to be 42. Quick scanning for the mode. Do you see any values that repeat themselves? No. So we will just say no mode. And then do make sure you say no mode if there isn't one. Don't just leave it forgotten. And then our mid-range, we'll take our smallest, our minimum, 38, plus our maximum, 60, and divide by 2. So we get 98 divided by 2, which is 49. I want you to stop and reflect on which measure do you think best represents a typical student's Wi-Fi usage and why. Use that information that we talked about on the previous couple of slides and come up with a response. You'll also be asked in your exit ticket, which is posted on Blackboard, to close out the lesson there, which you will receive points for. So please make sure that you go on there and participate in that exit ticket. Okay, and lastly, a couple of reminders for you. Your problem set 5 corrections were due today, November 24th. That was Monday. We were supposed to be in class. You were going to bring those to class with you. So if you were doing those on paper, fine, that's fine, but you can't bring them to me, so post them on Blackboard. Please do make sure you take a clear picture and upload them to the original problem set on Blackboard. Coming up next week after Thanksgiving, we will review for the final exam. I've also posted a few items for you on there as well. There's a study guide with a list of topics to start